All right, Happy New Year, everyone. I tested positive for COVID, so I'll be out probably till next Wednesday. Until then, we're just going to work on some notes. So each day I'll post a video. It'll probably be about 20 minutes. It'll be me going through the parts of the notes that I would usually do on the board, and then I'll leave various examples for you to do in class. And so for each class, I want you to open up the video, go through it. If you want to pause it while it's happening and do the ones that I'm not doing, you can do that. If not, just watch it all the way through and then go back and do the ones that I haven't done. And that'll be your assignment for each day. Okay, so I'm going to get started. We're going to start off with Unit 5. We finished Units 1 through 4 before break. This one is a pretty quick unit. There's not too much to it. The main things are sort of classifying triangles and then classifying when they're congruent. Our first step in all of this is just getting down some definitions, so this won't be too interesting, this first part, but it's important to know what an acute, equilateral, and obtuse triangle are, and all these types. Okay, so an acute triangle is a triangle where all of the angles are less than 90 degrees. So this would be an example of an acute triangle, because all the angles are smaller than 90. If you remember from what we've done so far in class, if your angle is like skinnier, so this is about a 90 degree angle. If the angle is like smaller than that, then that would be an acute angle. This would be 90 degrees. Anything wider than that is obtuse. And that's how we're going to classify. That's one classification for a triangle. So these are all classifying a triangle based on its angles. These are based on its sides. So all angles are acute. Okay. For an equiangular triangle, that means all angles are equal. Obtuse triangle, one angle is obtuse. So you only need one angle to be obtuse for it to count as an obtuse triangle. You don't need three angles. Right triangle, one angle is a right angle, which is 90 degrees. Okay. So let's go through. I'm going to just label each one of these based on our angle things. So for this, all of these angles are acute. So I'm going to say that's an acute triangle. This one, I've got a 90 degree angle. And as long as one angle is a right angle, it's going to count as a right triangle. So this would be right. This one, I've got one angle is bigger than 90 degrees. So I get one angle is obtuse, which means greater than 90 degrees. That's a greater than symbol. So this would be obtuse. And then this one, all the angles are less than 90, and they're all equal. So I can say equiangular and acute. It's going to be both of those. Equiangular, we don't use that term a whole lot outside of geometry, but you will see acute, right, and obtuse. Okay, so those are classifications for a triangle based on the angle. Now we can do the same thing for it based on its sides. So equilateral triangle means all sides are same length. LNG TH. Cool. Isosceles triangle. Two sides are same length. I spelled it wrong. Length. And then scaling triangle is no sides are same length. Okay. All right, so I'm going to go through. Actually, I'm going to leave this one for you. There's three different triangles here. There's ADB, triangle ADB, and then I want you to label that as either acute, equiangular, right, or obtuse. There's triangle DBC, and there's triangle ABC. So we got this big one here, we got this little one, and then this little one as well. So I want you to come up with the labels for each one of those. I'll do some examples of classifying by sides here. So you say either they're isosceles, equilateral, or scalene. So isosceles means two sides are the same. Equilateral means all sides are the same. Scalene means no sides are the same. If you see these tick marks, if two sides have the same number of tick marks, that means that they are congruent. It means that they're the same length. In more complex diagrams, you might see like arcs on the each of the angles. So those will like show you that those are congruent. Also, different numbers of tick marks. Like if I had 3 tick marks here and 3 tick marks there, that means that these two sides are the same. Anyway, this triangle has two sides that are equal, so I would call that isosceles. This one has no sides that are equal, so I'd say that's scalene. Okay. M is the midpoint of JL. Name and classify all 3 triangles in the diagram as equilateral, isosceles, or scalene. Okay, there's a trick here. I'm going to do the trick for you, but I'm going to leave you with having to like label each one of these. Sorry. Yeah, I'm gonna have you do the classifying. So the tricky part here is saying that M is the midpoint of JL. That means that it splits like this line segment and this line segment so that they're the same. So it takes this big line segment, cuts them exactly in half. So this segment is the same as this one. The way we denote that in a geometric diagram is we'd put the same number of tick marks on this segment as this one. This one already has 1 tick mark, so I'm going to put just another tick mark there. All right, the other part that you need for this is that this big length is 16. All right, so what that means is that this length is 8, and this length is 8. And any length that has 1 tick mark should also be 8. So this will be 8. All right, now you should be able to go through, identify the 3 triangles, and write which ones are, and classify each one of them as equilateral, isosceles, or scalene. Okay, I'm going to do this one for you, and then I'm going to have you probably do these next few. Okay, so find y and the length of GH if the following triangle is equilateral. So equilateral means that all 3 sides are the same. Okay, so that means that 3y minus 3, that's one of our sides, is equal to 5y minus 19. Right? Because these 2 sides are equal to each other. I'll just label it like that. So let's do, I'll solve for y. So minus 3y on both sides. We get negative 3 is equal to 2y minus 19 plus 19. We get 16 equals 2y. Y is equal to 8. Okay. And then it asks for the length of GH. So GH would be 3 times 8 minus 3. So 24 minus 3 is 21. So GH equals 21. Okay. I think you should be able to get through both of these, classify them based on their tick marks. I want you to classify following triangles by sides and, oh no, it doesn't show you angles. So just do it by sides. And then you should be able to go through and find x for each one. All right, that should probably take a little while. We're probably about halfway through where I want to get to today. The next part is the triangle sum theorem. You'll use this in SAT math and just general math classes for the rest of high school and onward. If you go into engineering or any STEM field, you need to know how to do this. The triangle sum theorem is really important, like for future math and science. It says that the sum of the measures of the interior angles of a triangle is 180 degrees. All right. These are interior angles. These are exterior angles. So it says that if you added up that angle plus that angle plus that angle, you're always going to get 180 degrees. All right. So measure of angle A plus B plus C equals 180. Okay. I'm going to go through the proof of this. We're going to use a couple of the things that we've seen from before. All right. So what I'm going to try to do is I'm going to try to show that angles 1, 2, and 3 all have to add up to 180. The way I'm going to do that is I'm going to do a geometric proof. I'm going to draw an extra line there. And I'm going to start off by saying angle 4 plus 2 plus 5 equals 180, because that's the angle addition postulate. Because if I add up these three angles, they make a straight angle. A straight angle has 180 degrees in them. So any straight line has 180 degrees. If I split it in two like this, then I'd say that they're like a linear pair, so they add up to 180. If I like split it up again, the three angles will add up to 180. So I'm going to say angle 4 plus angle 2 plus angle 5 is equal to 180. Okay. I'm going to say that is the angle addition postulate. So now what I got to do, I'm trying to get to the statement 1 plus 2 plus 3 equals 180. Angles 1 plus 2 plus 3 equals 180. The way I'm going to do that is I'm going to say that angle 1 and angle 4 are congruent. So angle 1 is equal to or congruent to angle 4. My reasoning for that is they are alternate interior angles. Same reasoning for angle 3 equal angle 5. That would be alternate interior. Okay. So now what I'm going to do, I'm going to do substitution twice. So instead of writing angle 4, I'm going to write angle 1. So let's say angle 1 plus angle 2 plus angle 5 equals 180. Again, I'm just rewriting this statement, but where I see an angle 4, I'm going to replace it with angle 1. Okay, and then for the last statement, I'll do angle 1 plus angle 2. I'm going to substitute again. Wherever I see 5, I'm going to replace with angle 3. Okay, so this is an example of using proof to show why something that's used in geometry and beyond is true. So we start off with this fact: if we add these three up, we'll get 180. Using our steps for proof, we can show that that means that the interior angles of a triangle always have to add up to 180. This is our statement that we're going for. We actually got there. Okay. Yeah, I'll just do a couple of these as an example. These get harder. The ones that are harder are the ones that are more similar to an SAT one. I remember one almost exactly like this from it was either the PSAT or the SAT, one of the packets that I've given you so far this year. All right, so I'll do this one. So 31 plus 78 plus 1, angle 1 equals 180. So I just say angle 1 plus 78 plus 31 equals 180. Add these up. So angle 1 plus 31 plus 78 is 109 equals 180. Subtract 109 from both sides. I get 71 is equal to angle 1. Pretty simple. Okay. For one of them, like this, you're going to have to use like some more tricks going on. I'm going to leave this one for you. This one's pretty tricky. I'll give you a bonus point if you can figure out how to do this one. I'm going to have you take pictures of your notes and put them on Google Classroom. Probably, I kind of only want to collect that once, so I'll probably have you do that next Tuesday. But I'll check for this one for bonus points. Maybe even just for like when I come back. But these will all take different tricks. Like for this one, you got to say that angle 1 and 57 form a linear pair. So you'd say that angle 1 is the same as 123, because 123 plus 57 equals 180. So you can label that as 123, and then you can solve these two. You should all be able to do this one very straightforwardly. This one, again, tricks, like you see that these are both have one arc. That means that angle 1 and angle 2 are the same. So that means I could say like 2 times or angle 2 plus angle 1 plus 105 equals 180. Because angle 2 and angle 1 are the same, that's the same thing, like 2 times angle 1 plus 105 equals 180. Or 2 times angle 1 is equal to 75. And then just divide by 2. I get angle 1 is equal to, I think that's 37.5. Cool. Yeah. And that would mean angle 2 also has to equal 37.5. Yeah. but I'd like you to try each one of these. You all should be able to do this one, and this one pretty straightforwardly. You can finish off this one and then do that one if you're interested in bonus or a challenge. Okay, what time are we at? We're at 15 minutes, so we'll probably do another 5 minutes. Let me see, where's a good stopping place. Okay, we'll stop just before the exterior angle theorem. We'll do that for our next class. Find the missing angle. What is the relationship between two acute angles in this triangle? Okay, so I'm going to go through this. So we'll just get our set of statements from this. This says we got a right angle, so this angle here is 90, right? Whenever we see that box, that means 90. These three angles have to add up to 180. 90 plus 40 gives me 130. 130 plus what gives me 180? Oh, that's going to be 50. All right, so I could write that down. 90 plus 40 plus question mark equals 180. Looking for the question mark. 130 plus question mark. 180 minus 130. That equals 50. Okay. Now, what this is trying to show us is that if you've got a right triangle, you can look at the two angles that are not right angles, and you can say, oh, those are always going to add up to 90, right? So if one of my angles is 90, then my other two angles, to make it so that all three add up to 180, the other two have to add up to 90. So we can say that the two acute angles, which are the two other angles in a right triangle, they have to add up to 90 degrees. Okay. You can use this. Okay. I'll do this proof, and then I'm going to have you do 12 and 13. I'm going to pick up with 13 in my next video. So I'll go through the proof for number 11, and then I want you to spend the rest of your time going through and doing the problems that I haven't, that I left for you to do. Okay, so for this, I'm going to say that angle A plus angle B plus angle C equals 180. Okay, we say that's the triangle sum postulate. Okay, so you're not going to have to do proofs for like the test or the quizzes in this unit. So this is just using proofs as a way of showing you why we know this, or just like to see proofs again. All right, measure of angle C is 90, so I'm going to say angle A plus angle B plus, instead of C, I'm going to say that's 90 equals 180. All right, this is substitution. You could also call it def of right angle. So if an angle is a right angle, then it's it's always going to be 90. So now what I'll do is I'm going to subtract 90 from both sides. My new statement is 90 is equal to angle A plus angle B. All right, so that was the subtraction. POE. Okay, awesome. So let me just go through quick the parts of this that I want you to work on, and then I'll give you an update in our next video on Friday. Okay, so on the first page, I want you to classify these three for number 2. On the second page, I want you to classify the 3, so identify the 3 triangles here. Classify each one of those. I want you to do number 7. So both of these, you need to classify each one of them and solve for x. Page 3, I want you to do this one, and this one for sure. Do this one if you want more of a challenge. Again, this is good at practice for standardized tests, and if you get this right, I'll give you a bonus. You do have to find how many different angles? 6 different angles, so that'll take a while. And then on page 4, I want you to do just number 12. We'll pick up with number 13 in our next video. All right, good luck.